Welcome. In this video, we'll be looking at functions and graphs. These are the learning objectives if you want to know what we are going over today. First of all, what is a function? It is a relationship between a set of inputs and a set of outputs, where each input is defined to exactly one output, and you might see a function as y equals or f of x equals in some later examples. First, a word problem. So a gym membership has a pay-as-you-go program, and it is a one-time membership fee of $30 plus $8.50 for every class. How much will it cost for one class, two classes, 4, 7, or 10 classes? You need to set up your function, which would be 850x plus 30 equals y, and this is because you have a one-time membership fee, and then your 850 changes on how many classes you take. You would set up a table, and here shows your number of classes, 1, 2, 4, 7, and 10, plus your change in cost. So for one class, you're basically multiplying 1 times 850 and adding that to 30, or for 10 classes, you're doing 10 times 850 plus 30, and you get $115. And we're going to take these correspondences as ordered pairs and graph that. So here is our lovely graph, and since this is a linear function, we could use it to predict classes in between, so 3, 5, 6, even up to 12, or 100 classes if we so wished, but I won't go that far. For 5 classes, it would be $72.50. For 12 classes, it would be $132 total. And we could use this to predict even further if we wanted to. So our gem function would be 850x plus 30 equals y. So if we didn't want to graph the function, we could use this to solve for other numbers of classes as well. And the total cost y is dependent on the number of classes attended, which is x. X is your independent variable because of how many classes you're taking, and y is your dependent variable because it's changing on how many classes you're taking. In a function, the first set is called the domain, and that's all of your x values. The second set is the range, which is all of your y values. In a function, each single member of the domain has exactly one member in the range. So let's say each person has their own DNA, and this is a function because each person has their own DNA. You can't have somebody else's DNA, then you wouldn't be your own person. To each truck sold, you have that price, and this is a function because you can only pay one price for a truck. To each real number, there corresponds the square of that number, and this is true because the square of 2 would be 4, the square of 4 would be 16, and you can't have a different square for those numbers. To each math teacher, there corresponds many students' questions, and this is not a function because one teacher has to deal with many questions. We need to determine if the following correspondences are functions. So in our first example, we have -7, +7, -4, +4, and 0 in our domain, and then in our range, we have 49, 16, and 0. So we look at -7 and +7 both go to 49, and this is an example of squaring them. So -4 and +4 go to 16, and this is still an example of squaring them, and 0 goes to 0. This is a function, so each member in the domain has one member in the range, even though they share members in the range. The second example has the appointed president and the Supreme Court justice during their time in presidency. Ronald Reagan had William Rehnquist, Sandra Day O'Connor, Robert Bork. Richard Nixon had Harold Carswell, William Berger, and William Rehnquist. Theodore Roosevelt had William Day, and Oliver Holmes. Grover Cleveland had Melville Fuller. So this is not a function because not every member of the domain has only one member in the range, and it's specifically because William Rehnquist shares both Ronald Reagan and Richard Nixon. A relation is the correspondence between the first set domain, your x values, and the second set range, your y values, where each member in the domain corresponds to at least one member in the range. So are each of these a function? If you had all of the cars produced in 2020 and a set of VIN numbers, yes, this is a function because each car has its own VIN number. If you have a set of cars in a parking lot and a set of License plate numbers, yes, this is also a function because each car has its own license plate number. If you have a bag of chips on a shelf and a set of weights, no, this is not a function because chips could share the same weight, or you might have a brand of chips with different weights. And then the next one, you have a set of band members and a set of instruments. Yes, this is a function because most instruments only have one person playing them. You can't share an instrument. For this example, you need to identify the domain and range. Remember that domain is your x values and range is your y values. So for the first one, your domain would be 9 and 2. Your range would be -5, 3, and 6. This is a relation, but it is not a function because your range has to share domain values. For your second one, your domain is 2, 3, and 4. Your range is 10, 15, and 20. This is a relation and a function. For your third example, your domain is 0, 1, 2, and 3. Your range is 1. So this is a relation and a function. Even though all of your domain numbers share your range, each domain goes to one range. So your range can share domain numbers, but your domain cannot share range, which is why C is a relation and a function, but A is a relation but not a function. Here you have a function x squared minus 9x minus 12. Let's say you want to find what it equals when x equals -2. You're plugging in -2 for each x value. So -2 squared minus 9 times -2 minus 12. You're following order of operations, y equals 10. Or maybe you want to find when x equals 0. You're still following order of operations, y equals -12. Or for positive 2, for x, you're finding that y equals -26. But the reason I have this slide is you won't always see y equals, you might see f of x equals. And that's just the same thing, but instead of y equals, this tells you that you're plugging in -2 for each value, or you're plugging 0 in for each x value, or +2 for each x value. You'll follow the same steps, it just looks a little different. For this function, we need to find f of 0, f of -5, f of 4z, and f of p minus 3. Which the first two are straightforward. You're plugging in 0 for each x value and -5 for each x value. And you're going to find that f of 0 equals 3 and f of -5 equals 58. But for f of 4z, you're plugging in the whole 4z for each x value, and you end up following order of operations the same way. And your answer would be 32z squared minus 4z plus 3. And for f of p minus 3, you're plugging in the whole p minus 3 as a value for each x. So 2 times p minus 3 squared minus p minus 3 plus 3. And you're still following order of operations to find your answer 2p squared minus 13p plus 24. Let's say you want to graph this function. Since this is an x squared function, your domain is not limited in any way, so you can choose any x value and then solve for your y values. So for -3, you get 4 for a y value, -2, -1, -1, 4, 0, -5, 1, -4, 2, -1, and 3, 4. And then you can connect all your points. And here is your lovely graph. Let's say you want an x cubed function. Your domain is still not limited, but here we see that we have 3 values for y in a row, so you have to choose -1/2 and +1/2 to find which way your graph will curve. And you can find that -1/2, y value would be 0.375, and for +1/2, your y value is -0.375, and then you can connect those points. If you have a square root function, you have a limited domain, so you can see that I have everything from -3 to +3, but if I had -4 for an x value, my y value would be imaginary, so I cannot go beyond -3 for this particular function. I might for other functions, but not this one, because it's imaginary beyond this point. So here's our lovely square root function. A vertical line test states that if a vertical line crosses a graph more than once at a single point, then your graph is not a function. So here we have this graph, And if you were to drag a ruler across your screen, would your ruler cross this graph more than once? And no, it would not. So this graph is a function. If you have this graph, however, your ruler might hit your graph at 2, 3, or 2 spots at once. So no, this graph does not pass the test. It could pass it through 2 or more points at one time. It's not a function. This graph could pass the vertical line test. It is a function. This graph could not pass the vertical line test because it could hit the vertical line at 2 points at any point in the graph, so it is not a function. This graph, could it pass the vertical line test? Yes, it can. So even though we have 2 points, one is open, one is closed, saying that one point is within the function and one point is not included in the function. So this is going to pass the vertical line test. If you need to find the domain of a function, you are looking at the real number of inputs and the outputs given by the formula. Your domain is all the inputs. And if an input is not defined, then it's imaginary and you're thinking about the square root function and it is not a domain, so it would be imaginary. If you have f of 1 and f of 5, you need to find for this function 1 over x minus 5. First of all, f of 1, you'll find that it is negative 1/4, so the domain of f of 1 is negative 1/4. If we plug in 5, 1 over 5 minus 5, your function is undefined. Therefore, f of 5 is not in the domain of this function. We need to find the domain of this function 1 over x minus 8, and we need to find when the denominator is equal to 0, because then this function would be undefined or imaginary. So we solve for x minus 8 equals 0, x would be 8. So all of your domain would be all numbers except for 8, and it could be written, and you read this as x, such that x does not equal 8. Or you could also write it as negative infinity to 8 union 8 to positive infinity. Here you have the function 3x squared minus x plus 7 over x squared plus 2x minus 3. So you need to find when your denominator equals 0. You need to factor your denominator, x plus 3, x minus 1, set those equal to 0, x equals negative 3 or positive 1. Your domain is all numbers except for negative 3 or positive 1. You can rewrite that as x such that x does not equal negative 3 and does not equal positive 1, or negative infinity to negative 3, union negative 3 to 1, union 1 to infinity. You're using parentheses on these. You need to find the domain for x cubed plus the absolute value of x. This can be any number. Your domain is not limited, so it is all real numbers from negative infinity to positive infinity. If you need to think about how to visualize domain and range, your domain is all your inputs, all of your x values, and range is all of your outputs, all of your y values. Find the domain and range of this graph. So your domain is negative infinity to positive infinity. Your range is negative infinity to positive infinity as well, because your graph is not limited anywhere. For this graph, your domain would be negative infinity to positive infinity. It includes all x values. Your range is negative infinity to positive 4 with a bracket because it includes positive 4. You could also rewrite y such that y is less than or equal to positive 4. Here you have a square root graph. Your domain is negative 4 to infinity, and you have a bracket at negative 4 because it includes negative 4. And then your range is a bracket 0 to infinity. Here you have a cubed graph, and your domain is negative infinity to positive infinity. Your range is also negative infinity to positive infinity, is not limited. Here you have another graph. So your domain is negative infinity to negative 3, union negative 3 to positive infinity, because you have an imaginary vertical asymptote blocking your graph. Your range is negative infinity to negative 2, union negative 2 to positive infinity, because you have an imaginary horizontal asymptote that your graph will never cross. Here you have another graph. Your domain is negative 2 to 3. Your range is 0 to 2 because, and you have the brackets because all numbers are included, nothing is excluded. And thank you for listening. And that is all for this video.